Hey everybody, welcome to another episode of Daily IoT. On today's episode, we're going to be continuing with our Turkey Temp Tracker project with the WiPy and Losant. But before we do that, I want to give a brief shout out to DIYODE. This is an electronics maker magazine out of Australia that did a feature on our texting dryer project. That if you've been watching for a little while, that was a project we recently did where my dryer will send me a text when the cycle is done. The folks at DIYODE thought that that was a cool project and created a feature article in here, so shout out to them. Not a paid endorsement by any means, but I highly recommend if you're into making and electronics to subscribe to DIYODE. It's a great magazine, packed with content. This is the November issue. I will link this up in the description. You do not need a subscription to view this particular article. They have it on their website as a feature article. But like 100 pages, you know, there's ads in there and stuff, but I mean, 100-page magazine of maker things, highly recommend. I love it. You should check them out. I will put a link up. Again, not a paid endorsement. I just think it's a really cool magazine. Even cooler now that we've made it in as a Daily IoT, one of the Daily IoT projects. So let's talk about our Turkey Temp Tracking project. Man, I am probably 20 hours into this one. And loving every second of it, by the way. I mean, hating lots of seconds of it too, but overall loving all of it, learning a ton of things, specifically around analog to digital converters and all sorts of stuff, and the WiPy platform from PyCom as well. But I want to briefly talk about what we have, and then I'm going to show you just a little bit of the code that's running on the WiPy, as well as how we can go about setting up the backend in Losant to be able to accept readings from our hardware. So let's talk about the PyCom for just 1 minute. The PyCom has a lot of potential. It's really cool. One of the things that I'm really passionate about is getting everybody into making an IoT. And one of the big barriers historically for that has been access to hardware. Nobody wanted to write assembly or C on microcontrollers. And so the hardware has come a long ways. We have all these platforms, Raspberry Pi and things like that, and Photons and PyCom devices and Arduinos. So we've really caught up there, but the language barrier is still there for a lot of people. I know how to write in this language and I can't on that platform, so I'm not even gonna try. Even though you're totally capable and you should, that's not a good excuse not to. But so what's really interesting about the PyCom devices, the WiPy in our case, is that it's programmable in Python. So if you know how to program in Python, now this is opened up to you without any extra overhead or learning. And so I'm really a big fan of platforms exploring new higher level languages to be able to write and hack in. And so very excited about that. The shortcomings of the WiPy is that it's just not there yet. There's a lot of oh, this will probably be fixed in a little bit. They're still iterating a lot. And so there's a lot of shortcomings in the setup. The documentation is good, but very lacking in many areas. And so I'm really excited about where PyCom and specifically the WiPy is going, where the trajectory, but right now I can't recommend it as a beginner platform if you've never done any maker electronics. There's still just enough hurdles that I think you'd get frustrated and give up, but not on this show. There are no giving up. There's no giving up in Daily IoT. I pushed through a lot of the documentation shortcomings and things like that. And not even just about the PyCom, the ESP32 chip that is the heart of this. I have been reading the data sheet on that about the analog to digital converter that's inside of it. And just, I wish I could have like a 4-hour episode and just brain dump all of this cool stuff that I've learned. So, but I'm going to figure out how to do that in nice little chunks over the next few weeks, hopefully. But I got sidetracked there on the PyCom. I'm really excited. The platform's not there, so I can't recommend it as a beginner platform yet. But for our project, we have got hardware. We have reached a point of hardware complete where I have my thermistors. Here's one of them, and here's the other one. Oh, get back in my turkey there. Connected to the onboard analog to digital converter. I didn't think it was going to be able to handle it, so I bought an external one. An ADS 1115 that we turned out not needing to use. We are using the onboard analog to digital converters on the WiPy, connected up to our thermistors, and we're getting readings on our device. And so what we're going to talk about, and I'm going to show you here in just a minute, is how we now take this hardware setup. We're getting good readings from our thermistors, and how we translate that into a Losant dashboard. And so what we're going to do today is I'm going to show you a little bit of the code that's running on the WiPy, and then I'm going to walk through how we set up Losant to be able to accept readings from our physical real-world device. So that's the whole concept with a platform like Losant or any other cloud platform, is that you have your hardware in real life here, and you want to get that up into the cloud and be a virtual representation there so you can act on the data and do cool things. And so that's what we're going to show you. Let's start in the code for the WiPy, and then we'll move on to the Losant setup. All right, I changed my mind. We're going to change the order of things. We're going to start in Losant and then take a look at the code on the WiPy. So I am logged into my Losant account here on my applications page, and we're going to create a new application. And the application name, I've already typed. Turkey Temp Tracker is what we're going to call it. You know I don't do descriptions, don't be ridiculous. We're going to click Create Application, and now we have our application. And what we need is a way to connect, again, our physical real-world device to a representation in Losant so that we can connect the two together. And so, as you can see here, it says no device is found. We're going to fix that by clicking on Create Device, and we're going to create a blank device. And from here, we'll just call this the Temp Tracker device. No description. It's a standalone device type for Losant purposes. And then we have this section here called Attributes. And our physical device has two sensors on it, two thermistors. And so we have two attributes that we want our Losant device to correlate to with our physical device. And so we're going to call one of these the oven for the oven temperature, and the other number we will call food. And so those are the two attributes that our device will have. That's the readings from our two thermistors. We don't need any device tags, so we'll just come down here and click on Create Device. Now that we have our device in Losant, we need a way to connect it from our WiPy to Losant. And for that, we're going to use the Losant MQTT broker. And as any good platform will do, we can't just randomly send data from an untrusted source. And so we need to have some sort of credentials to access our Losant backend from our device. To do that, we're going to come over to the Security tab, and we're going to create an access key. We're on the Access Keys page here, and we're going to click Add Access Key. And I'll give in and put a description here so we know that this is our WiPy device. Like that. We're going to restrict access, so this key is only going to be good for the device ID associated with Temp Tracker, our Temp Tracker device. So once we have all that, we can click Create Access Key. And this is, as a side note, I love this little UI touch that Losant does here. They give you your access key and your access secret. However, for security reasons, the access secret will not be visible again after you close this dialog. So if you don't get the information right now and you find out that you need it in 2 minutes, you're going to have to delete the key and create a new one if you didn't copy this down. And so they give you a way to copy it and or download it, but you cannot close the window until you've done that. So I really like that UI touch that forces you, hey, there's something important here. Don't just close the window because you're in a hurry. So I'm going to download the file so that I have it, click the consent that I do have that in a safe place, and then we can close the window. And that's it. That's all that we need to do in Losant to create this virtual representation of our device and make it so that we can connect to it. I'm going to come back over to the Devices tab here, and I'm going to click on our Temp Tracker device. And you can see that I have a device log that says it's listening. No logs yet. I haven't connected to it or sent any readings to it. And so that's what we're going to take a look at now, which is the code that's running on the WiPy that will connect to Losant. So let's take a look at that. Here we are in the Atom text editor, which is what PyCom uses to interact with its devices. They've created a plugin for the Atom editor that allows you to update firmware and things like that on the device. And so this is the source code. Let's take a look at it very, very quickly. I'm going to put this all on GitHub so you can look at it, so I'm not going to spend a lot of time. looking at this, but a quick primer on PyCom devices, in our case the WiPy. We have these two main files in all projects, main.py and boot.py, which in my case you can see is empty. You don't have to put anything in here. And if you're familiar with Arduino projects, you can think of these somewhat like setup and loop. The setup function on your Arduino projects will run once when the device turns on, and then loop will run continuously. Similarly, on the PyCom devices, boot.py, the code in boot.py, will execute when the device boots up, and then main.py will run after that. The big difference here is that main.py is not executed over and over like the loop function. It will run once. And so if you need an infinite loop of taking temperature readings or things like that, all of the flow control is your responsibility here in main.py. So those are the two files, main.py and boot.py. And then you also have this lib folder that you can see over here where you can put libraries in that you can pull into your project. In our lib folder, I've created a couple of libraries. I created this thermistor.py and this Losant MQTT.py. Thermistor.py is just a simple module that I created for doing the heavy lifting of getting the reading from our ADC on the WiPy and turning it into a temperature reading. So not a whole lot going on there, but a very nice abstraction so that we can interact with it over here just by newing up a thermistor and then doing a read temperature on it. And so for each thermistor, there's some things that you have to know about it, like its nominal temperature and resistance and beta coefficient and things like that. And the big difference, you'll see that they're all the same except for this argument right here, which is the series resistor. Remember, the thermistor is a variable resistor, and it's connected to another resistor to create a voltage divider. And that other resistor affects the overall analog output voltage, and we would like to know that as accurately as possible. So even though they say they're 1 meg resistors, I threw them on the meter and got the actual readings so that we could get a more accurate reading from our thermistors. And so that's what that argument is right there. The other library that I created was this Losant MQTT. So Losant has created a Python library to interact with their backend service through the MQTT broker. However, it's not meant to run on MicroPython, which is what the WiPy environment is. It's a MicroPython environment. So there's not a lot of the high-level libraries that the Losant implementation requires. And so I took their implementation, stripped out the device class, and create a very trimmed down version that uses the micro MQTT library to connect to Losant's MQTT broker. So this is mostly Losant code that I copied and, like I said, trimmed down and modified just a bit to use the micro MQTT library. As a point of note, the out-of-the-box MQTT library from PyCom does not work with the Losant backend. From what I can tell, it has something to do with the connect message and the format of that, but the micro MQTT library, this library right here, works just fine, and so I swapped it out for that. So those are the two libraries that I added. You can see the micro MQTT, I just copied that in from the Git repository, and that's all we need for supporting libraries. The code here, very simple. We set up our analog to digital converter to have an A and B channel for our thermistor, and then we have this run function. And as you'll see in just a minute here, this is not how we will leave it when we're ready to use it on Thanksgiving Day. This is still in a test mode where I want to be able to boot up the WiPy and run this function to make sure everything works. And all this is doing right here is connecting to my Wi-Fi network. I have this separate config file, which I will not show you, that has all of my private information in it, like my SSID and my Wi-Fi credentials, as well as all of those Losant variables that we just saw. The Losant device ID, as well as the API key and secret, are stored in that config file so that we can read those in. And then that's it. We're going to new up a device, connect, and then 10 times in a row, we are going to send the oven and food temperature from our oven and food thermistor objects. And so that's all we have for the code. Like you can see here, less than 40 lines of code. This is a helper function down here that you can ignore as that I'm using as part of my testing. And so that's it. Not bad for connecting to Wi-Fi and sending data to Losant. So let's see how this works in action. So I've plugged in my WiPy device, and you'll see that once I connect, I get a spew out here of the boot up sequence, and it just drops me right into a Python prompt. It says MicroPython version 1.8.6, and this is just a normal Python prompt. You can do things like 2 + 2, and it'll give you the answer. Now, again, this is MicroPython, so you don't have access to everything that you do in a normal Python execution environment, but the syntax and how everything else works is the same. This is just Python, which is really, really cool. I really love how this works. And what we're going to do from here is I'm just going to call my run function that I have created here, which is going to connect to my Wi-Fi and then try to connect to the Losant backend. So I'm going to go ahead and click run, not click, I'm going to type in run, call it, I'm going to hit enter, and then I'm going to tab back over, and we're going to keep an eye on the device log here. It should connect to my Wi-Fi. Oh, and there we go, perfect. You'll see I get a authentication succeeded, connection succeeded, and now it's sending my state. Remember, I have that on a loop 10 times every 5 seconds to send a new temperature reading. So let's expand one of these. You can see here the payload that it receives. It's got a food temp and an oven temp from our thermistor. So that is exactly what we were hoping to see. And that's it. That's all we need to do on the Losant side of things. Very short. You saw how quickly. You just go in, you create a device, and we're good. We're connected. We can now flow data from our physical real-world device up into the Losant platform and do some really interesting things, which is what we will talk about in tomorrow's episode, this concept of a dashboard in the Losant world to take all of this simple readings from thermistors and turn it into really cool, actionable, interactive data. And so stay tuned for that tomorrow. Question of the day. If you were paying attention during the Losant setup, we had to assign a couple of attributes to our device in Losant. And I say attributes, but I've been hearing a lot more people in recent years say attributes instead of attributes. And so the question of the day is, which camp are you in? Do you say attributes or do you say attributes? Let me know down in the comments. If you have any questions about any of this, please let me know. You can put them down in the comments. You can reach out on Twitter, send me an email. I love hearing from you no matter how you reach out. So send questions my way. I'm happy to help. And thank you so much for watching Daily IoT, the show where together we're learning how to make the Internet of Things one day at a time.